Greetings and welcome to my new calculus channel. So, in one of the Discord discussions that we were having, I talked a bit about the origin of the tangent line concept. So, the root word, which the root word of the tangent line in Greek, which in Greek is ephaptomeni, is aphi, okay, which means contact. So, in 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 Greek, the word for touch is aphi. In Latin, it's tactus, okay? And the word for tangent line, aphaptomeni, is tangens in Latin, okay? So aphaptomeni is a tangent line and tangens is also a tangent line in Latin. So the Greek word epaphi means to touch or to contact, okay? To contact, and in Latin it's contactus, all right? So maybe it would help if we just wrote these things down. So, the Greek word for touch, we want to do this. Okay. So the Greek word for touch is aphi. Okay. And the Latin word is tactus. Okay. The Greek word for tangent line is aphaptomeni. It's ephaptomeni. What am I doing? Ephaptomeni, like that. Ephaptomeni, and it's tangents. I'm putting the accent in here. And to contact means epaphi, epaphi. And in Latin it's contactus. Okay. And the word I made up is the following. Ephaptometro. Ephaptometro. Okay. And in Latin that would be tactus meter. Tactus meter. Okay. So this word here means it's a combination of touch and meter, and it means to measure smoothness. Okay, so that's the original definition of the Greek word and that's how the concept came about. In other words, if you have a tangent line like this, its main purpose is to measure smoothness of the curve. That means if you have to get to any point on the curve where it's not defined or it's not smooth, there is no tangent line there. Okay, so the whole idea here is that it touches. So now, what did the chimpanzees of mainstream mathematics media do in the last 150 years? Okay, so they decided they were going to redefine. So I'll get back to this definition. They decided they were going to redefine tangent line as follows: taking the limit of a function from the left, and if it's equal to the limit of the function from the right, then a tangent line is there. But in this case here, there is only one function. Okay, there's only one function. And the issue here is that the limiting value is not defined at the point of tangency. And that's kind of paradoxical, isn't it? Because if tangent lines, tangent lines that's a chief characteristic of a tangent line is to touch. But now, with this definition here, they no longer even touch at the point of tangency. Okay, so if you, for example, bring the slope from this side and you try and put it over there, it disappears. It's not defined anymore because there's no secant line which becomes a point. Okay, secant line can't be a point. Okay, see how it disappears? Gone. Right. So then what the chimpanzees did next is they added the garbage of piecewise functions. Okay, so now this is what really made them change the definition. But the problem now is that it's not the same function. Okay, so you don't have one rule here. Okay, it's not one rule. So if you look at this here, you now have more than one rule, and you're looking at more than one function. This must be the same as this. Okay, but it's not. As you see over here in the graph, this section here is not the same function as this one here. Okay, it's not the same function. All right. So while it's okay to say, oh yeah, it approaches from the right and the left, there's still the issue that it no longer touches the curve, which is its main definition. Can you see how much they've actually fucked up everything? Because they're such morons, okay? They're such imbeciles that they don't understand these things. So there's another word, Greek word, which was used, which is nepsis. Okay, now that word is written, I think, like this. Hang on a second. Like this. And it means to verge towards or to incline towards. Okay, so if you have a curve and a point there, it means to verge, for the lines to verge towards that point. Okay, so while it's a property of a tangent line that the secant line slopes verge towards the tangent line slope, first of all, it must be defined there, because if a tangent doesn't touch, it loses its main function. Okay, it loses its main attribute, which means to touch. Okay, it needs to touch at that point. If it doesn't touch, there's a problem. All right, there's no tangent line there if it doesn't touch. I mean, if we have to go back up here, I can show you that for this function here, it's defined at this point, but this function here is not really defined at that point. Okay. In fact, because it goes from 8/3 to 7.5. Okay. So Merriam-Webster originally defined tangent as a meeting of a curve or surface in a single point if a sufficiently small interval is considered. All right. That was originally intended to rule out the possibility of the tangent line crossing over. And indeed, there is actually a inflection point at 2/3 over there. So this point here, there wouldn't be a tangent line there. Okay. So, but they changed that as well, because now a function with their definition has a tangent line at a point of inflection. But that's not the original meaning. Okay. And it's wrong. So later on, Merriam-Webster added this. A tangent line is a straight line that is the limiting position of a secant of a curve through a fixed point and a variable point on the curve as a variable point approaches the fixed point, but never reaches it. Okay. So now what you have is a limit, the limiting value, which is not defined at the point of tangency. It's not defined. Okay. In other words, I mean, what are you talking about? You're stripping the tangent of its main characteristic. That is, it touches at a particular point. That's why they've pummeled themselves into a corner with all the bullshit about being differentiable at a point, continuous at a point. So they've got all this confusion amongst themselves. And basically, I think that one of the reasons they have piecewise functions is just to make their exam questions more interesting for students. But in reality, you never get this type of thing. Okay, it's rare that you will have a model in reality which has more than one rule. Okay, so there are two rules here: this rule, okay, this rule, and this rule. They're different rules. You cannot apply calculus over this region here. Okay, you cannot apply calculus over this region. It has to be smooth. The methods of calculus are null and void unless a function is smooth. I mean, if you have more than one tangent line there, okay, then it's not smooth at that point, and you cannot use the mean value theorem. Okay, what does the mean value theorem say? It says that at a particular point of the slope function, which is the derivative, that's what it's a derivative is, a slope function, that this finite difference, b minus c, gives you this slope. And I've already discussed this in previous videos. And of course, this here is really the fundamental theorem of calculus, because if you multiply both sides by b minus c, then you get what is the integral from a to b of this function, okay? So you get both the integral and also the derivative from that definition. That's why the mean value theorem is so important. But I've discussed that in other videos, so I'm not going to discuss it again. So let's just summarize. The tangent line meets a curve in one point, extends to both sides, and never crosses at the point of tangency. That is the correct definition of a tangent line. If you're not a rare subscriber, become one. Click like and follow me on academia. I haven't written an article on this, but there are many other articles that talk about it. So tell your friends about this, tell your teachers, tell your parents, tell everyone you know. Till next time, I'm John Gabriel. Goodbye.